we have learned 3 different methods that you can use to solve a system. Now remember, when you're looking to solve a system, you're looking to get the solution, right? The x value and the y value that will work in both of the equations. Now, we've learned how to solve a system by graphing, by substitution, and by elimination. But how do you decide which one to use? Like if someone's like, oh, here, solve this system. How do you decide which method to use? Here's the thing. I can use any method. All of the methods will work on all systems. Here's the thing, is that some of the methods will be really easy for one system and really hard for another system, right? These methods will vary a lot in how long they take or how difficult they are. So we want to make sure that we're always choosing the easiest method for a particular system. That's going to save time and it's going to prevent mistakes. So when should I use graphing? Well, if I want to use graphing, first of all, I have to have a graph. So like if you don't have a graph, it's like a little inconvenient to use graphing and you might just choose something else, okay? So the other thing is that let's say you had an equation and it said 3x plus 20. Well, if you had a y-intercept of 20, you'd have to have a graph that goes up to 20. So that's something to consider, right? That it's just like a matter of convenience. Like you have to have a graph that's big enough to graph the equations. The other thing that would maybe make you want to choose graphing is if the slope is a fraction, because fractions are really easy to graph. But it would be kind of annoying if you use substitution, you would have to do math with a fraction, which is like not horrible, but whatever. So the disadvantages of graphing, right, is that it doesn't allow for large numbers unless you have a big graph, which you usually don't. And it doesn't give decimal answers accurately. Like if I were to graph an equation, right, if I were to graph this, and they intersected and it wasn't quite on the grid lines, it'd be pretty hard to say like, oh, that's 2.27, right? Like we couldn't really read that off a graph. So, but when you get 2 equations that look like this, they're both in slope-intercept form, right? Remember, slope-intercept form looks like this, y equals mx plus b. If you get 2 equations that both look like this, these are easy to graph, and you should just graph those, and they'll intersect at a point, and that'll be the solution. Now, when should you use elimination? Elimination should be used when you're giving 2 equations in standard form. Okay, remember, standard form looks like this: ax plus, right, a number times x plus a number times y equals a number. So these kinds of equations, if you get 2 of those, you should for sure be using elimination. That's going to be easiest, especially if you already have a pair of coefficients that are opposite. So like, for example, let's say this was negative 4x and this was 4x. Super easy to use elimination. This one is not that, right? Like here we would have to multiply this bottom equation in order to, like I could either multiply it by 4 to get negative 4 and 4, or I could multiply it by 3 to get 9 and negative 9. But that would be the easiest method for something like this. Okay, now remember, with elimination, you may have to multiply one or both equations, right? Like with level 1 elimination, we talked about just being able to add them. Level 2 and 3, you do have to do a little bit of multiplying, like here. Now, substitution. Substitution is one that is used in a couple different situations. One is a situation like this. Let's say I have, there's a variable by itself, and that variable is equal to this. What you would do is you would just, take this 5x minus 7, and you'd plug it in for y. Right? And then you'd have an equation that would only have x, and you'd solve, and you'd get x, and you'd plug it back in. So this kind of situation is one situation where you might use substitution. The other situation where you might use substitution is where you have 2 equations in slope-intercept, right? Kind of like this, okay? But like, let's say the numbers are too big to graph. That would be another situation you'd do substitution. So like, let's say you had y equals 3x plus 20, and y equals negative 5x minus 40, right? You're not going to have a graph that goes from negative 40 to 20. So this would be easier to just go ahead and take these 2 equations and use what we learned in substitution, where you set them equal to each other, right? That way you would use substitution for. Okay, so that's kind of where you would use those 3 methods. The notes are here, so you can reference them, but you're going to go ahead and for each of these systems, you're going to look at this and you say, what am I going to use? Graphing, elimination, or substitution? You're going to say which method you would use and why, and then you're going to go ahead and solve it using that method, and then make sure to check your answer. So you're going to go ahead and try this first one.